Let's now look at cloud native application, a kind of a overview. And in the recent times, we keep hearing about this cloud native application development, and the requirement is growing. So let's see what it is. So to understand it, we need to look at the evolution process, the software evolution process in different timelines. 1980s and 90s, we had waterfall model, and application was monolithic, and there was physical servers. You had the physical servers, um, and then if it is kind of a big corporate Fortune 500 companies, all the physical servers were lined up in the data centers. So 2000 is what agile. This again a development. These are development methodology. The waterfall is that if you have some project management background, the waterfall is like your requirement needs to be frozen, and then you develop the application based on the requirement. You define the functional document, get the sign off, then you do the development, and then the testing, and then it is deployment. So once deployment is done, the project team is nowhere going to be available. It's sent into the operation team or the support team, which takes over the process. So that is the waterfall. The agile is something like requirement. Then based on the requirement, you develop and provide an output, and then they will further refinement happen, further functionalities will be added. It's called a sprint. There are different sprint wherein on this sprint you will have stories. Initially there'll be maybe 10 stories. You develop an application based on that stories, and maybe the critical ones are developed first, and then the add-ons will be in the next sprint. So the process will be something like, instead of waterfall here, in case of agile, it's also called kind of a spiral model. It keeps going on and on and on like a spiral. So, and application, yes, it is the entire, meaning you are able to segregate it, like the one tier might be the database, then you will have the application tier, and the third tier is the internet or the browser tier. So they call it three-tier architecture. Earlier, it's all there in one server. It's called as client server technology. Like the client might be a dump machine through which you connect to the server, maybe something like a mainframe computer where the dump terminal connects to the mainframe system, and it works. And here then there was a segregation, database tier, application tier, and the browser tier. That's where the virtual machine came into play as well. You have a physical server, and then the physical server is partitioned, and it's partitioned into different servers as virtual servers. And you can even it's where cloud slowly, of course, cloud started catching up after maybe around 2010 is what the cloud-based system, pay as a service or pay as you go. Like if you want to host a website, then there is hosting service providers like GoDaddy, and so many. A part of the server is allocated to you with all the necessary software available. So we saw hosted environment. 2010 onwards, DevOps came into picture, development and operation. So it is similar to the agile model, continuous development and continuous integration. So there is actually no segregation between the real segregation between the development team or the operation team. So they are tightly packed in such a way that the process goes on. The dev process, development and operation process keeps continuing, continuous deployment and continuous integration happens. And all this, they had the microservices. To use microservices, you need containers, and finally, containers are generally on the cloud. So that is where post 2010, you had clouds. On the clouds, you had the virtual machines. On the virtual machine, microservices, and microservices is what is Dockers, and Dockers is classified as containers, and containers, when it needs to be orchestrated, that is where Kubernetes comes into picture. So that is what is about 2010. Again, after 2010 is what we saw the last layer. Last layer is what is the cloud native application. You need to have DevOps, microservices, containers, and you're operating on the cloud, then it is cloud native applications. So cloud native application DevOps is a set of development practice, combines integration of development and IT operation with the automation. So DevOps utilizes continuous integration and continuous development to quicker deliver software features and enhance business. So if you look at it, it is all the more something similar to the process of Agile, wherein you have this sprint, you have the user stories, and then you develop based on a set of user stories, you develop and release it, and then once it gets into the integration process over, then you have a new set of stories, or if you have some backlogs, those backlogs are taken into the next sprint. The sprint is a development process, so it can be anywhere between a 1 week to 3 weeks interval, and the development happens, and then again it goes into the integration or deployment. So DevOps is a kind of a refined, I would say that it's a refined process of what we had as Agile. So DevOps lifecycle from initial software planning to build, test, provisioning, configuration, deployment, and ongoing management. So it is kind of a spiral. So the process is going to repeat again and again. So we saw that, earlier we saw a pictorial representation. So microservices is an architectural approach for developing application. It's a collection of small services. Each service implement business capabilities, run its own process, all the dependencies, everything is packed together. It is again independent of the operating system. So if you say we want to run a Python program, even that necessary binaries for running the Python program is there in that component. All that is there embedded in the component, so it will run irrespective whether you have a Python installed or not. With the microservices, that is what happens. Once you make an image out of it, that's the microservices. So it can run independent of the platform, independent of the dependency. So the microservices part, yes, it's all images, and the images has a container, and that's what is that's where you call it as Dockers. The point over here, contain images with containers, Dockers, and orchestration of containers is what is Kubernetes. So containers offers both efficiency and speed compared to standard virtual machine. Again, standard virtual machine, even though you say virtual machine, it's all, there are dependencies like how many CPUs, how much is the memory. Yeah, you can make it automatic to make the necessary memory added up. But still, in case of containers, you have all the dependencies built into the container. So that is where you don't leave out anything. So it can work independently. So using operating system level virtualization, a single OS is dynamically divided into one or more isolated container, each unique writable file system or resource quota. So that's where I said like images with containers, with all the images as all the dependencies, and it is in a container, and that's the Docker. And orchestration part is what is Kubernetes. So this chart will make it much more clearer, cloud native application and traditional application. So it is independent of the operating system. Instead of so the developers can focus on development instead of focusing on configuration, patching, maintenance of operating system. Team focuses on the software. They focus on basically creating, building an image, post-building an image, as we saw earlier. An example, we made a Python program. So hello from Docker, so made it into build that image with a container, and then we ran that. So we when you do that, yes, even the Python binaries are built into the image, so it is independent of the Python interpreter as such. Otherwise, if you want to run a Python program, say for example in a OS dependent traditional model, if you want to run a Python based program, yes, you need to have a Python interpreter which needs to be installed on if you're using a Windows based machine, then yes, the Python part should be based for the Windows-based machine, and if it is Unix-based, then or Linux-based, it needs to be the Python needs to be for that specific platform. So it is traditional model is OS dependent, that is operating system dependent, whereas cloud native application is not like that. So the other one is you have right size, scaling up and scaling down is possible. Continuous delivery we saw, whereas it is waterfall model, and in case of traditional approach, automated scalability and elasticity. It can be based on the need. You can add up or scale down or scale up, whereas in the traditional model, it is manual scalability. So I think this will give you a gist of the cloud native application development. Basically, this diagram, if you look at this diagram, is what is very important. The last one, DevOps, microservices, container, and all this needs to be on the cloud. So that is the cloud native application development. Thank you.